Hi, we're going to talk about the velocity problem in this short video. The velocity problem has to do with an object moving in a straight line. And so for a little demonstration and experiment, what I'm showing you now is a small bracket moving across the tray of a whiteboard next to a meter stick with a stopwatch going on. And then from this experiment, what we're going to get is the position of the bracket at every time t. And we'd like to be able to use that information to be able to determine what is the velocity of this bracket as it moves forward and backwards on the tray here. What is its velocity at any given time t? So we made a little experiment there of just dragging a bracket across the tray of a whiteboard, but this could apply to any situation where you have motion essentially in a straight line. It could apply to a train moving on a straight track. It could apply to an object which is thrown straight up in the air, or maybe dropped off the side of a building and moves in a straight line. But for our experiment, I went ahead and I recorded the position of our little bracket for every time t, and was able to create a nice graph of all of the information. And I'd like to answer the following questions. What was the velocity of the bracket at time t equals 10 and at time t equals 52? Well, I can't answer that question. What I can do is get an estimate or approximation of the answer by calculating the average velocity. The average velocity is simply the change in position divided by the change in time. So maybe if I found the position at time t equals 10, the time at t equals 11, and then subtracted those divided by the change in time, which would be 1 second, that would give me an estimate. So I went ahead and did that, and I found my estimate to be 0.5 inches per second. Now, that's probably not a very good approximation, so the way that I can get a better approximation is to choose a shorter time period. So maybe instead of checking the time at t equals 11, I could check the time when t equals 10.5. And what is the position? Find the difference between the position at t equals 10.5 and the initial position when t equals 10, and then divide that by the change in time, which would be 0.5. And then if I want to get even better approximations, well, I choose values of t which are even closer to 10. And they could be closer either on the left side or the right side, meaning after 10 seconds or before 10 seconds. And as I get closer and closer to the value t equals 10, I can see that the estimated value for the velocity gets closer and closer to a single number. And so I could reasonably say that the velocity when t equals 10 is going to be approximately 0.3307 inches per second. And I can do the same thing with my other point. When t equals 52, at that time the object is moving to the left, and so the velocity is negative. And again, I just take values of t which are closer and closer to 52, either after 52 or before 52, and I can see that as I get closer and closer, the estimated values for the velocity get closer and closer to negative 1.0446. But these are only estimated or approximated values. The problem is that I can't calculate velocity because my only way of calculating velocity requires me to have two displacement values and two time values. If I only have one time value, how am I going to be able to calculate the velocity? Well, that's why we study calculus.